and he'll be speaking around Anoma's intent-centric architecture.
Thank you very much. Welcome. Thank you very much for coming, everyone. I'm Adrian, one of the co-founders of Anoma, and today I'm here to talk to you about Anoma and intent-centric architecture. Really, Anoma being the first of its kind here with regards to intent-centricity, and really like the most fundamental thing that you can take away here is that intents are coming, whether you like it or not. Anoma is the first of its kind, but there will most likely be many more, and I would expect that any new system going forward, any new L1 is going to be built around intents, because they are fundamentally the base unit of abstraction. Whether you are thinking about building on a rollup or a DEX or a MEV front-running application, everything revolves around intents, because intents are fundamentally what users have. Users don't have transactions. Transactions are a myth that Bitcoin created and Ethereum made programmable, but fundamentally users don't have transactions, they have intents. And so without systems that can reason about intents in space architecture, it's going to be very difficult to build incredibly scalable and privacy-preserving applications going forward. To begin with, I'd like to briefly go sort of through the evolution of protocols to justify a little bit why Anoma is the first of the third wave of base layer blockchains. And I'd really like to start with generation 1. Think Bitcoin and Bitcoin-like systems. And this can include things like Zcash, Monero, Dash, Litecoin, you name it. Anything that had scriptable settlement. Because the scriptable settlement part is really the key feature of generation 1 blockchains. And yes, they gave us a bunch of cool things. They make, under some people's opinions, relatively good forms of money. They allow you to build things like colored coins, Namecoin, and a long tail of Bitcoin-like forks. But fundamentally, they're very limited, right? Like, you can't build arbitrary applications on these systems. And so based on this, we got generation 2, a programmable settlement. And this really was spearheaded by Ethereum in 2015, where colored coins all of a sudden turned into ERC20s, Namecoin turned into ENS, and then we also got a bunch of new things like DAOs and NFTs along the way. And I think a bunch of people in this room may try to bite my head off for saying this, but generally speaking, we haven't progressed past generation 2. We are right now at programmable settlement plus plus. When you look at things like Solana, Near, Polkadot, Avalanche, Aptos Suite, doesn't really matter. All of these systems, even the rollups like Optimism, Arbitrum, Starknet, they're all really programmable settlement plus plus systems, because they don't move away from the fundamental notion of being transaction-centric. And yes, we've made tremendous advances, right? Like, we've made tremendous advances in what these programmable settlement plus plus systems can do, such as advances in proof of stake, advances in scaling with regards to sharding and rollups and so on. Advances in consensus, advances in interoperability. This is especially where like something like Cosmos and Polkadot comes in, which is they don't really fit well into this roadmap because they're kind of orthogonal developments with regards to interoperability, the interoperability and consensus space. But generally speaking, they're still programmable settlement plus plus. And then we're starting to now see generation 3, and these generation 3 systems are fundamentally intent-centric. And as I said in the beginning, there will be many more like Anoma, just like we've seen many sort of versions of Ethereum over time and many versions of Bitcoin over time. But Anoma is the first fully generalized intent-centric model, which really came about because we sat down at some summer month a couple of years ago and really thought hard, like, what does it look like to rebuild this architecture, like the blockchain space from scratch, from first principles. Great. So what is Anoma? Intent-centric architecture. I've been using this word a lot. We'll go into what intents actually are a little bit later. But fundamentally, the thing to remember is that Anoma's architecture is designed from the ground up for applications that involve infinite numbers of users issuing infinite numbers of intents, each of arbitrary complexity. Because intents in the end are just code, but they're partial state transitions. Think of a transaction as a transaction can achieve some specific state transition on a system. As in, I send money to X. This is something that is immediately executable and settable on any base layer. Most things don't actually look like this. For example, I want to trade asset A for asset B. This is not settable anywhere. This is not something that I can take to Ethereum and execute today. I fundamentally need a counterparty. And sort of in the DEX space, this counterparty would be that someone wants to trade B for A, or I can talk to an AMM where then the AMA input is my counterparty. But fundamentally, most things look like partial state transitions or intents. Even rollups here are falling under this category where it's like, I have an individual intent that wants to go into a rollup, but I need a bunch of other rollup intents that can be taken together and actually combined into this rollup. Whether this is optimistic or ZK doesn't actually matter. So, what are intents? It's fundamentally the notion that users express what they want, not how to get it. And this is, again, one of the very easy ways to see the difference that most of the existing execution environments that we have, like the EVM, really, a user, when they sign a transaction, they specify an execution trace. They specify an entry point and a bunch of opcodes that are allowed to be sort of modify their state. They don't specify specific state changes, which is why you get a horrendous amount of bugs along the line, because users don't know what's happening unless they fully simulate the transaction, because they don't actually, they know that they've signed over some opcodes that are allowed to change their state, but they don't know exactly what state they've authorized. Due to that, if you have broken smart contracts somewhere in the middle of this execution trace, you end up with stolen funds. And this is also very difficult to compose because if I only sign over state changes, it is very easy for me to net out the state changes. If I sign over execution traces, the interleaving now matters. Where it's like if I have transaction 1 and transaction 2, the ordering matters, which is where most of the MEV actually comes from. Whereas if you sign over specific state changes, it doesn't matter how you apply these state changes. What only matters is that these state changes are composable, because if I want to trade A for B and you want to trade C for D, we can execute them in arbitrary orders, and as a user, I fully authorize a specific state change. So the ordering on the execution side doesn't matter anymore. Yes, and this is fundamentally necessary in order to enable decentralized counterparty discovery. So this ability to say, I have an intent that goes from some arbitrary state A to some arbitrary state B, who takes the other side of this? Who, in the trading example, I want to trade ETH against Bitcoin, who takes the Bitcoin against ETH trade? Right now, really the answer that we have to this problem is we centralize it into some AWS server. This is what OpenSea does, right? Like OpenSea runs a single sequencer or matchmaking engine somewhere in California. This is what all the rollups currently do with a single sequencer model. This is where counterparty discovery currently happens. And it's really hard to get away from this unless we move to an intent-centric world. And yeah, this leads to this very nice feature that you get declarative paradigms for dApps, where users only specify specific state changes rather than how they interact with a dApp on a sort of very close level or low level. Right, this is sort of a high-level overview. For this, actually, I have to step over here to walk you through this a little bit. So on the far left here, you have the users. And users can really make a choice here. They can issue transparent intents, shielded intents, or private intents. And the difference really is whether you use transparent intents, then you're fully transparent, like you would know from nowadays systems. Shielded intents use ZK proofs. And private intents use fully homomorphic encryption. This is sort of feasible in the architecture, but fully homomorphic encryption is going to take another couple of years, depending on which cryptographer you talk to. They will give you different figures on how feasible fully homomorphic encryption is at the moment. Users sign these intents. And again, they can be arbitrary in scope. So intents are fully programmable. They can say, I want to trade A for B if the weather is nice in Paris, and if the weather is nice in Seoul at the same time, I want to also trade A for B and C. So fully programmatic. Now, these intents can be gossiped around by intent gossip nodes. You can think of the intent gossip network as a sparse, non-consensus critical gossip network where different gossip nodes can opt into different intents. For example, my node can say that I am willing to gossip all intents. Someone else's node can make a trade-off that the computation isn't worth it, and so they only want to gossip, let's say, fungible token trades. So different intent gossip nodes can specialize. And not every intent gossip node needs to have the same view of the network. However, intent gossip nodes receive fees for routing, so partial fees effectively. Like if you participate in the routing, you can, as an intent gossip node, decide how much of a fee you want to take. Yeah. Then you have solvers. By the way, in this sort of intent gossip and networking generally is like another 2-hour-long talk on how to actually make this work in practice. If you're interested in this, come speak to me afterwards. Then you have solvers, and solvers are non-permissioned entities. Solvers really are the front runners, or the generalized concept of front runners, or MEV searchers right now, which is they look at a number of intents and go, well, these 3 things are compatible. I can form them into a valid, fully fledged state transition as a transaction and submit them on chain. And here, I'll come to this if I have time in deployment models. This may actually mean many different chains. This may mean many different security models that you submit these transactions to, because Anoma is an architecture that can be deployed into many different deployment models or security models. Yes, then you have an encrypted mempool using Fairview, using threshold cryptography, so that once these transactions actually proposed, they're not front-runnable. So validators only include fully encrypted transactions in a block. On the next block, the validators jointly decrypt. Any 2/3 of the network can decrypt all transactions in a block. And then on that next block, these transactions are executed. If you're familiar with Tendermint consensus, this is actually how Tendermint works under the hood, that you have commitments or execution of order transactions in block n+1. Yep, now you have a finalized block. You start executing the transactions, and on the far right, you have the actual execution environment that can handle transparent, shielded, and private intents. And this is called Tiger. This is one very large circuit based on Halo 2, using Halo 2 as a proof system. You can also check this out, github.com/anoma/tiger. It fully works. And effectively, this allows us to have transparent applications be completely compatible with private or shielded applications within the same model, where applications don't, and this is probably the coolest things, applications don't pick the privacy model. This is fundamentally a user choice. This is not that there is a private DEX and then there's a transparent DEX. There is a DEX and the user makes a choice on whether to interact with that DEX privately or transparently. Because the only thing that changes is the intents authorization field effectively, and that could be a plain text signature or it could be a ZK proof. Yep. Actually, how am I doing on time? Seems fine. Right. So what can you build with Anoma? So you can build a lot of known dApps, but in a fully decentralized fashion. Everyone is starting to think about how to actually decentralize a rollup. The answer is you need intents and you need intent gossip, and you need this kind of settlement system. A bunch of people will try to reinvent this from scratch. This is much harder than it sounds. This is like not a trivial thing. So anyone that just goes, yes, we will decentralize, I'm going like, I don't think you've thought about this problem hard enough and long enough, because afterwards you will realize it's not trivial. So you can build things like decentralized rollups, whether optimistic or ZK. You can build actual decentralized order book exchanges. So DEXs that don't use AMMs, where the counterparty is always the chain, but rather use actual P2P trading. Things like DYDX and 0x actually. NFT marketplaces are a good example. Gitcoin quadratic funding is another good example here of something that you can build in a fully decentralized fashion. Again, not many people actually realize this with Gitcoin, but the actual quadratic matching formula is being run in some Excel spreadsheet and then submitted on chain. This is not actually verified on chain. We sort of just hope that the person doing this, the person running the sequencer, is doing the right thing. And maybe you're starting to notice a pattern here, which is that lots of the existing applications really just have this under the hood, the generalized idea and notion of intents. Just no one has so far sort of generalized enough across this entire space of the applications that we've built. But really, there is, from an architecture perspective, no difference between 0x, Gitcoin, and Arbitrum. Like, they're the same thing at a fundamental level. But you can also build very novel things like runtime rollups. One of the very cool things, since everyone just has intents in Anoma, if I have an intent from A to B and you have an intent from B to C, you just create any solver in the network can just create a partial rollup from A to C, right? And like the by the way, all the letters are like arbitrary states that you can target. So any solver in the network can do a partial rollup, and then if, for example, a day later someone has the state transition from D to A, the next solver in the network can take the A to C rollup and the D to A intent and combine them into fully fledged transaction that is settable on chain. This also makes lots of things more composable because users fundamentally don't have to pick between specific rollups. Like they don't have to pick between the green rollup and the red rollup. They can just like go, I care about the security model and which one do I care about? And then whatever is the next rollup block that is being proposed is just being executed and the user's in it. Yeah, you can build multi-party, multivariate bartering. You can build private trading dexes. So think something like OpenSea, where you actually, which is a dex for NFTs, right? But where users never leak the data of not only what they trade, not leak the data of who they are, even to the operator or the sequencer. Because this is sort of like a lot of the model in the existing privacy-preserving applications is, yes, you're private except to the person that does the sequencing. Which is kind of a weird model if the sequencing is being done by arbitrary entities out of the Caymans. So this is something that you can build with Anoma that you can't build anywhere else. And really, this is one of the fundamental reasons for this is Tiger. Yeah, privacy-preserving DAOs as well. And then there's a bunch of like sort of more out there ideas around plural money, collaborative finance, heterotopia. Again, if you're interested in them, talk to me later. Right, so, okay. As the last thing, I just quickly want to run through CowSwap as a fully decentralized example. Because there's another interesting component of Anoma. The fact that we have threshold cryptography in order to have an encrypted mempool also allows us to expose this as a primitive to applications. So applications can define their own threshold decryption strategies, as in you can have batching at the application layer, where an application like CowSwap can come along and say, I want to have my batches be 10 blocks long, and they shouldn't be decrypted until the end of the batch. Now you start having encrypted batches of intents on chain, just for data availability. After 10 blocks are over, the validator set decrypts and publicizes all the intents. At that point, we have a fully established ordering though, so no one else can add new transactional intents into this. And then a number of solvers can compete with each other to propose an optimal solution, which is then submitted on chain, let's say in the submission window of another 5 blocks, where the application on chain actually picks what is the most optimal solution. Like one of the things that, again, currently most of this of enforcing the batching as well as picking the most optimal solution is currently done on a centralized Web2 server, run somewhere in Berlin, I think. But yeah, this is sort of, with Anoma, you can start building these kinds of applications in a fully decentralized manner. Yes. Right, so on the topic of novel dApps, it was very hard to say in 2015 when Ethereum came out what kind of applications were going to be built on Ethereum. I expect this to be true here too. The design space is sort of like increasing by an order of magnitude of what you can do with intents. So yeah, let's see. Let's see what intents actually bring to the space. Just super quickly on deployment models, Anoma is an architecture. That's sort of very important to understand. This is an architecture that can be deployed into many different deployment models because fundamentally, different users care about different security models. My parents may very much like their local government, and they want to be on the government-owned chain that can do arbitrary state resets based on like real-world actions, right? And this is like, it's absolutely their right to be able to pick this kind of security model. But if you maybe somewhere in Argentina, you don't trust the local government, and you want to be on global Ethereum security. So different users and different people in the ecosystem will have different security models. It's not to say that everyone wants to be fully decentralized, because it's mostly not true. Different people have different security requirements. And so with Anoma, you can use this as an L1. You can deploy this as a sovereign L1. So think globally, fully decentralized blockchain. You can also deploy this as an L1.5 to decentralize specific applications on existing security models. So you could use the global Anoma, but have the application be still secured by something like Ethereum. So think CowSwap, where the counterparty discovery and solving component is done on Anoma, but the settlement actually happens on Ethereum. Or the next case is you can also deploy Anoma as an L2 to the blockchain of your choice, because in the end, the entire state machine is just one large ZK rollup using Halo 2. So yeah, you can take Anoma as an architecture and really deploy this into the security model that you care about, whatever that may be, and sort of no judgment. Yeah, so this is super quick. This was Anoma. It's founded by me, Awa, and Chris. And if you want to learn more, find me afterwards. Thank you very much.